Hello everyone, welcome. In the previous week, we learned about two supervised learning methods known as k-nearest neighbors as well as decision trees. So today we are going to begin with the idea of evaluation of a model performance. So for this, we are going to come up with a quantity which can tell us how good our model performs. So first, let us consider this data set which has two features with the first feature called x1 and the second feature called as x2. And the label for those points is given by y, and you can see 4 points are with label 1 and 4 others with 0. With the graphical representation, we see that 1 comma 1 with label 1 is indicated with green all the way until the other 3 points, which is until 3 comma 6 with and 3 comma 6 and 4 comma 4 with labels 1, and there are four more points with the label 0 indicated by red color in this graph. So in the previous week we saw decision trees, and today we are going to have a look at few models of decision trees and then subsequently evaluate how they have performed on this particular data set. So the first model is x2 less than 3.5. If x2 is less than 3.5, we ask this particular question, and if the answer is yes, then the points belong to class 1, whereas if the answer is no, then the points belong to class 0. And if you recollect, class 1 was indicated by the green color and class 0 was indicated by the red color. Now, x1 is along this axis and x2 is along this axis. So if I look at the line, clearly this doesn't seem to be that great a model. And by this point, most of you might even have thought of what would be good questions to ask so that my points which belong to one particular class are on one side, and whereas the points belonging to the other class are on the other side. However, for this model, we see that it has gotten 4 points predicted correctly, which is 1 comma 1, which had the label 1, is still predicted as 1. 2 comma 3, which is this point, is also having the correct label as 1. Whereas there are these 2 points, which is 6 comma 3 and 8 comma 2, which had the original label of 0, but our model has now predicted it as 1, which you can just check using this question. So likewise, these 2 points are also misclassified, and clearly this is not that great a model. So now let's look at another one. So this is a second model, and this clearly seems to be better than the previous one because this time it says if the value of x1, that is here, is less than 3.5, you put it to class 1, which is the green points. And if the value is greater than 3.5, then they belong to class 0. So it looks like it has got almost every point correct except for this one particular point 4, 4, whose original label was 1, but it is now being predicted 0. It does look like we are coming closer to the good model. And now finally we have that model here, and clearly we can already see that it states if x1 is less than 5, you put it to class 1, and if x1 is greater than 5, you put it to class 0. And also when we have a look at the table, we see that it has gotten the labels of all the points correctly. So clearly we know that this model 3 has performed better than model 1 and 2. But the question is, can we come up with a quantity which can help us directly compare these three things? So firstly, here I've written the same x1, x2, which are nothing but feature 1, feature 2 here, and the label has 3 columns of the table, and the same predictions that we've already seen as the other 3 columns. So here we are going to define this quantity called as accuracy, which basically takes the ratio of number of correct predictions that your model has gotten divided by the total number of predictions. So in the case of model 1, if you recollect, it had gotten only 4 predictions correctly, which are again highlighted here. So this 1, 1, 1, 1 we see, and there is a 0, 0, and 0, 0. So for 4 points, it had gotten it correctly, which is why the numerator is 4. And there were 8 predictions to be done in total, so which is why the denominator has an 8. So this gives us the value 0.5, and this can also be said that the model has an accuracy of 50%. So when we look at the second example, we see that it has gotten almost all the labels correct except for this one particular point where the true label was 1, but our model has predicted 0. For the remaining 7, it goes in the numerator, so 7 by 8 gives us 0.875 and therefore an accuracy of 87.5%. Finally, as we saw, the model 3 got all the predictions correctly, and therefore it has an accuracy of 100%. So with this, we have come up with a quantity that can be used to compare the performances of different models, and let us see if this particular value is sufficient to say that our model is good. We'll be looking at a couple more examples on this in the upcoming video. Thank you.